pleasant and blessed day to all of you, my dear viewers. Welcome to Ma'am Jack's Math Tutorials. Our topic for today is about divisibility rules for numbers 11 and 12. But before we proceed, let me refresh you with the word divisible. When we say divisible, it means it can be divided. Or for example, we have 35 and 5. 35 is divisible by 5 because when we divide 35 by 5, it will give us a quotient without remainder. Now, let us proceed with the rule. First, we have rule for number 11. A number is divisible by 11 if the difference of the sum of the digits at the odd places and even places of the numbers is 0 or divisible by 11. So our rule is quite long and seems like confusing, but it only means that you're just going to add all the digits that you can find in the odds place and all the digits in the evens place, and then get the difference. Okay, so let me show you. So for example, we have 1,452. It says in our rule that we have to get the sum of all the digits at the odds place, followed by the digits or the sum of the digits in the evens place. Okay, but before we can do that, let us first identify what are the digits in the odds place and evens place by counting. Okay, from left to right. So let's number. First digit is our number 1. Second digit is our number 2. Third digit is our number 3. And the fourth digit is our number 4. And let us now identify what are the odd numbers in our numberings here. Do you know what are odd numbers? Okay, we have 1, 3, 5, 7, 9, and so on. So we have here two odd numbers. We have 1 and 3. So let's now get the digit on top of them. So what is the digit on top of number 1? We have 1. On top of number 3 is 5. So it says in our rule that we have to get the sum. So let's add. Add 1 and 5. So 1 plus 5 is equals to 6. And the next step is, let's get also the sum of the digits on top of the even numbers. So we have here two even numbers also. We have 2 and 4. So first, let's get the digit on top of number 2. What is it? It's 4. So let's write it here. And the digit on top of number 4 is 2. So let's get the sum also. 4 plus 2 is equals to 6. And the last step for us to identify if a certain number is divisible by 11, let's get the difference. Okay? So, the first sum, 6, minus the second sum, which is 6 also. So, 6 minus 6 is 0. Now, let's go back to our rule. If the difference of the sum of the digits in the odds place and the sum of the digits in the evens place is 0, therefore, the whole number 1,452 is divisible by 11. Okay? Another example, we have 978,351. So let's count the digits from left to right. Okay, we have 1, 2, 3, 4, 5, and 6. Okay. Let us get the digits at the odds place. So what are the odd number here? We have 1, 3, and 5. So what are the digits on top of these odd numbers? We have 9, we have 8, and we have 5. And then, what are we going to do? Let's add. Okay? We have 9 plus 8 is 17. 17 plus 5. What's the answer? Yes, it is 22. Okay. Now, let's get the digits in the evens place. We have the following even numbers. We have 2, 4, and 6. First, let's get the digit on top of number 2. We have 7. On top of number 4, we have 3. And on top of number 6 is 1. So, let's add also. So, 7 plus 3 is equal to 10. And 10 plus 1 is equal to 11. Now, the next step is, let's get the difference. Okay? So, the first sum is 22 minus the second sum, which is 11. So, 22 minus 11 is 11. Correct. Now, our rule says that if the difference of the two sums is 0 or 11, then that number is divisible by 11. Last example for number 11. We have 18,745. So let's count the digits from left to right. Okay. This is 1, 2, 3, 4, and 5. Then, get the digits in the odds place. So, these are the odd numbers, 1, 3, and 5. And the digits are on top of them. We have 1, 7, and 5. And then, let's get the sum. So, 1 plus 7 plus 5. So, 1 plus 7 is equal to 8. 8 plus 5 is equals to or equal to 13. And the next thing is to get the digits on the top of the even numbers. So, we have 8 and 4. And then, let's add also. So, 8 plus 4 is equal to 12. And always get the difference of the two sums. So, the first sum is 13 minus the second sum, which is 12. So, 13 minus 12 is equal to 1. Now, based from our rule, no, is 18,745 divisible by 11? No. So, this number is not divisible by 11. Why? Because the difference of the two sums is not 0 or is not divisible by 11. And the next rule is for number 12. A number is divisible by 12 if the number is divisible by both numbers 3 and 4. So, example, we have 648. So, we need to have a checklist. So, we have 3 here and 4. And let us identify if the number is divisible by both 3 and 4 so that we can consider the number as divisible by 12. Okay? First, number 3. Is this number divisible by number 3? So what is our rule for number 3? Add all the digits. And if the sum is divisible by 3, therefore, the whole number is divisible by 3. Okay. So 6 plus 4 plus 8, what's the answer? 6 plus 4 is equal to 10, and 10 plus 8 is equal to 18. Is 18 divisible by 3 or can be divided by 3 without remainder in the quotient? Yes, because 18 divided by 3 is equal to 6. So, let's check under number 3. Now, let's go to number 4. What is our rule in number 4? If you still remember. Okay. If the number formed by the last 2 digits is divisible by 4, therefore, that whole number is divisible by 4. Right? So, is 48 divisible by 4? Yes, because 48 divided by 4, it will give us what? 12. So, therefore, this 648 is divisible by 4. So, look at the 2 checks here. Can we now say that 648 is divisible by 12? Yes. Another example, we have 125,124. Now, let's identify if this number is divisible by 12 by applying the rule. So, let's identify first if this number is divisible by 3. So, again, what is our rule? Let's add all the digits. And then, if the answer or the sum is divisible by 3, it is divisible by, or the whole number is divisible by 3. So, 1 plus, I'm sorry, I'm getting out of ink. 1 plus 2 plus 5 plus 1 plus 2 plus 4 equals. So let's add. 1 plus 2 is equal to 3. 3 plus 5 is equal to 8. 8 plus 1 is equal to 9. 9 plus 2 is equal to 11. And 11 plus 4 is equal to 15. So let us give space to number 15. Okay, I'm sorry, no more ink. So 15. Is 15 divisible by 3? Yes. So, therefore, this whole number, 125,124, is divisible by 3. So, let's put a check. Now, let's go to number 4. Let's look at the last 2 digits. We have 2 and 4. So, the number formed by the last 2 digits is 24. So, is 24 divisible by 4? Yes, because when you divide 24 by 4, the answer is 6. Very good. So, therefore, it is checked also. Since it is checked, so this number is divisible by both numbers 3 and 4. Therefore, this whole number, 125,124, is divisible by 12. Okay? Let's have this last example. We have 6,726. So let's identify if it is divisible by both numbers 3 and 4. Okay, first, add the digits. We have 6 plus 7 plus 2 plus 6. Okay, so 6 plus 7 is 13. 13 plus 2 is equal to 15. And 15 plus 6 is equal to 21. Okay. Is 21 divisible by 3? Yes. So it is. Check. Because 21 divided by 3 is equal to 7. Okay? Now, let's go to number 4. Let's get the last 2 digits. So, is the number formed by the last 2 digits here, which is 26, divisible by 4? So, you solve 26 divided by 4. Okay? It's not divisible by 4. Because when we divide 26 by 4, it will give us a quotient with remainder. Okay? So therefore, based from our table here, this number is only divisible by 3 and not by 4. Therefore, this number is not divisible by 12. I hope you learned something from today's lesson. And please don't forget to like, share, subscribe, and hit the notification bell for you to be updated with the latest video lessons.